We're gonna get going here. Looks like everything's working. How's everyone doing? That looks good. Live on Twitch. Thank you, Mr. Certainly. Oh, I gotta switch my Discord to live broadcast chat. How's it going, Bruce? Let's shrink this down. Spook just moved out of the camera view. He'll probably go back in just a bit. Hi, folks. We'll get going in a couple minutes. If you have questions, go ahead and ask them before we do housekeeping. Hi, Juan Carlos. Mr. Certainly says, I'm doing well. How about yourself? I'm doing pretty good. Got through all my email. Have a few things to wrap up, but just got back from a quick walk. It's nice and sunny out, which is nice. Pavre6, hi. Thanks for hopping in. Bonome 2, not to be confused with ESP32-S2 polish. Pavre6 says, greetings, deep divers. Bruce S says, things are also awesome with the other Bruce. Where's the third? How many Bruces can we collect here? First snow of the season. We've had it freezing overnight a couple nights, but not that bad. I think the high's in the 50s today. It's pretty nice out. Mio Drag Cat says, hi, greetings from Austria. Hello, thanks for watching. We'll get going in just a sec. I just took my socks off. It's actually kind of warm in here. I'll probably open the window, but there's like yard work happening outside right now. Bruce S says, we've had snow and they're making the artificial stuff on the mountain. Yeah, I don't know if they've started doing the artificial stuff yet here. BX2D Core says, good afternoon, bright and sunny down here. Nice. Hi, Johnny. Johnny Bergdahl's in the YouTube chat. Mark Gambler says, had snow for too long this year. I think of Canada as the Great White North. Yeah, things are going pretty good. Yesterday was kind of heads down fixing some network stuff that I'll go over. Vin had our checkup yesterday as well, so her mouth is looking good. She's not in the room, but Spook did just move back into the cat cam. Let's see. He's there in the sun. He's been doing good too. All right, let's get this show on the road, shall we? I realized today that the time codes we should be trying to take are the YouTube ones, because that's where I put them. So I don't know, actually, can I see a time code here? No, I can't easily. Everything looks good. I think we got everything checked off. Cool. Oh, you know what I need to do is I need to share this link. So here's the notes doc. So if you go into the Discord server, I will put the notes doc here. If anybody wants to follow along or and get a sneak peek of what I was thinking. All right. So, hello everyone. My name is Scott, and I work on CircuitPython for Adafruit. CircuitPython is a embedded version of embedded version of Python from, yeah, somebody said they got banned from the Discord server. Well, I hope the mods reached out to you to tell you why. Anyway, yeah, I work on CircuitPython. It's a version of Python for teeny tiny computers called microcontrollers. They tend to be very inexpensive and things that you can put in a lot of different places. Oh yeah, I'm on cat cam still. I should probably be on me cam. Adafruit is an open source hardware and software company based out of New York. They contract with me to work on CircuitPython. I work remotely, so I'm in Seattle here. And yeah, so that's Adafruit and CircuitPython. If you want to support me and support Adafruit, go to adafruit.com and purchase some hardware there. We've always got neat stuff coming out. Quick hello to Hugo and Unexpected Maker and JH. Thanks for joining. This is a deep dive, which is about 2 hours of me just working on and answering questions around CircuitPython. It happens normally on Fridays at 2 p.m. Pacific. I'm in Seattle, so that's why. Occasionally we shift to Thursdays at 2 p.m., but today and next week are both on Friday. For those of you not in the U.S., beware that the U.S. changes daylight savings this weekend. And so double check the times for the stream next week, because it will not be the same time as this week for you if you're outside the U.S. Oops. And you've already done daylight savings. So here's just a link to every time zone for that. And I guess I'll put it in Restream as well. So that's the deal. We tend to go about 2 hours, and as folks have seen, I love to answer questions and dig into the weeds and stuff. So if you have questions about CircuitPython or electronics, if it's electronics generally, I'll try my best, but CircuitPython I tend to know, or at least can point in the right direction. If you want to hang out kind of in the longer term, you can join the Discord by going to adafru.it/discord. When you join there, check out the code of conduct. We do have a code of conduct, and we do discipline people if they don't follow it. So yeah, adafru.it/discord. It's a chat that lasts all week. It doesn't kind of limit you to just chatting when we're streaming here. So that's cool. And then last up, just a note about the cat. The cat in the picture is Spook. He is epileptic, which means he does have seizures from time to time. It's unlikely that he will have a seizure during the stream, but it has happened. So just a heads up there. What I'll do is I will just mute my mic and watch him for like 5 minutes while he does that, just to make sure he's okay. And then I'll just unmute and keep going. It's part of his life. So yeah, that's housekeeping. Hello to Benjamin Eggerstedt in YouTube. Thank you for joining. Hello, Emmett Ray. Glad you could join. From LinkedIn, hi, Jake Bentley. Bentley Cope. Nathan Phillips asks, does CircuitPython have a JSON parser? And the answer is yes. We use the JSON parser from the code that originated in MicroPython. So you should be able to just do import JSON like you would in CPython and be able to parse JSON strings that way. I did recently in 6.0 add the ability of any object that has a read into method, you can pass into there, and it will read one character at a time. Rather than doing the like read the whole string and then parse it all. So hopefully that'll mean that like peak memory use is less. Marie Meyer says, greetings, Scott, missing SuperCon this year. Yeah, it's pretty wild that we're not having any conferences, but I had one of my loyal viewers and actually GitHub sponsor reach out to me and say like, hey, I really appreciate your deep dives. They kind of don't fully fill that gap of like going out and seeing people at conferences, but at least give somewhat of that feeling. So Marie, thanks for hanging out. I hope that we can fill a little bit in from that gap of missing SuperCon. I had a good time last year. It was kind of a whirlwind. I feel like I did it just right after I was traveling or something. But yeah, I'm excited to do some of the core things. One of the things that I was really planning on doing this year is I was planning on trying to make it to Australia to go to PyCon Australia this year. Is the thing that I was kind of like thinking would be my big trip. Because I want to go down and meet the MicroPython folks down there, and that didn't happen, obviously because of COVID. Although I am excited. Here's me rambling a little bit, but so the Melbourne MicroPython folks do a meetup that Matt Trentini organizes, and they've been doing it virtually. And because the way daylight savings works across the equator, we go from 7 hours difference to 5 hours difference, which means that for me, in the summer it was at like 3 a.m. 3:30 a.m. that it would happen, but because the daylight savings shift is 2 hours, no, it's not. It must have been 2:30. But I think next week or next month when they have it, it'll only be 2:30 a.m. for me. So I'm excited that like through the winter I could probably make it, which will be cool. Unexpected Maker says that would have been awesome. Hopefully next year or 2022. Yeah, we'll see. We'll see if I make it down there. There's lots of things to think about with that. Emmett says you have to invent your own Python language. No, we don't. It's the languages is the same. We just make it work a little bit different. Johnny says the FPGA Python language. Yeah, I would love to get back to that stuff again. But if you haven't noticed, I tend to cycle through the projects I'm interested in. Hello, Jekyll's Magic on Twitch. Thanks for joining. All right, I think I'm going to open the window because it's already getting warm in here. Hopefully it won't be too bad. Oh, yeah. That'll keep it cooler in here. It didn't even phase Spook that I opened the window. He's used to it. When one door closes, Scott opens a window. It's very true. Johnny says not before 6.0 is out. All right. Okay, so here's the things that I had on my plan. Let me take a time code. And again, if you have questions, feel free to ask them. I love answering questions. But on my list are I got the Grayscale support checked in. I think I talked about it last week, but it's checked into both the library and the core. So if you use the latest version of CircuitPython, you should be able to experiment with that. That's Grayscale support for e-inks, e-paper displays. And let's see, do I have a... Oh, no. Uh-oh. I was just looking at my my test e-ink here, and it's got all this gobbledygook on it. I wonder if I loaded the wrong code or something on it. Oops. Hopefully I didn't check in a bug. Yeah, so that's Grayscale support. I did some Raspberry Pi bare metal stuff, so I thought I'd just talk about that a bit. I did a little bit of sleepio work, so I thought I'd just take a look at that. And then the kind of the meat of this deep dive that I wanted to talk about was a couple fixes for networking in the ESP32-S2. Hi, George. Anything interesting? Here's an overview of what we're going to talk about, and you tell me if it's interesting. But again, if you have questions, I'm happy to answer them as well. So the two things I want to talk about networking-wise is the way that the receive function works. We had to change it because it was causing lots of timeouts. And then also I started work on NTP and UDP support. So writing changing the NTP CircuitPython library to actually use a UDP socket to get the time. So that's the plan. if we don't have questions. But first, we got a question from Foamy Guy that I will take a time code with and answer. Foamy Guy asks, is there anything like display.io.release displays that allows us to release only a single display instead of all of them? No. So, for those of you who don't know, displays are really weird because they last longer than... Where's the color button? Displays objects last past the end of the VM. And the reason that is because when you get an exception, we want to be able to show you the exception on your screen. So if you have code and it initializes things, and it initializes the display and then runs and then crashes, like we actually want to show the crash. We do show the crash on the display. So we have this weird thing called display.io.release displays, which is the way that you kind of reset everything. And it's a very common pattern to call that before you do all the display initialization, because if you don't, then it will complain that like pins and stuff are already in use. So they're like the fact that we actually we don't really even support multiple displays. Like there's only the monster mask where we do, which I think is what you're using. But like we're not we're not I don't feel like I've done a good job supporting multiple displays. In particular, like how each display relates to each other. So that's why we don't really have a good option for just releasing one display and not both. Okay. So this is a good segue. We'll just reorder the topics a little bit. So Pavre6 says, can we discuss on bare metal on Cortex A series 2, please? Okay, so let's... yeah, sorry, Foamy Guy, I don't have a good answer for you. Okie doke. So let's talk the Raspberry Pi stuff. Ooh. So I'm going to read this question off just because I don't know the answer. So maybe other folks in the Discord or the YouTube chat can help. So Benjamin asks, when you look into the networking stuff, could you tell me/us how I could get hold of a wireless beacon to parse it myself? I'd like to see if WPA3 is there, but so far I can only go through SSIDs. Yeah, I don't know. I think that the scan does provide... the encryption level. I think that's what it's called. But I'm not positive. And then David says regarding displays, what about a virtual display so the user can manage/redirect output to individual displays? Yeah, I think that's kind of what I was thinking with the multiple display thing of like, you have two displays, but you want to like access them as if it's just one display. Emmett asks, what is this doing? It's a line of pure C code. And the answer is, I don't know, delete it because it's terrible. There is this competition for obfuscating C, and that's exactly kind of what this thing is if you ever see code like that, you should delete it and rewrite it, in my opinion. Okay, so sorry, I got distracted from the Raspberry Pi stuff, but I like it when code questions come in. So, I don't have it here. Let me switch to the desktop. So, I took some time last weekend and I did this tutorial. It's I could just link to it. I think I linked to it last week as well. But it's this really cool tutorial about bare metal on the Raspberry Pi 3. and I went through it, and it was actually quite easy to do and understand. Um, it's really, really straightforward. So I just used a Pi 3A plus. This is what my setup is. Let me switch. So here's a Pi 3A plus, and the A plus is interesting to me because the USB connector here is directly connected to the chip. If you have a B plus, either a Pi 3 or a Pi 4, there's multiple USB ports, and that means that there is a hub between the chip itself and the connector. But because it's directly connected here, it means that we can act either as a host or a device, hopefully. And if you use CircuitPython, you know that CircuitPython is all about you plug it in and it shows up as a drive. So that's why I'm particularly interested in the Pis that have direct connections. The Pi Zero also has that, where the USB micro B at this point is directly connected to it as well. So there's two here. One is for power and one is directly connected. Emmett says, it defines f as an array of unspecified size of pointers to functions that return pointers to functions that return void. Yeah, C obfuscation for the win, I guess. Yeah, so I basically went through all of this, and I did most of the examples. It's actually very straightforward because they have make files in them. So you just go here and you'll end up getting this kernel image 8 file, and then you just copy it to the SD card, start the Raspberry Pi up, and it runs that code. And they have examples for like, oh, you want to do UART output. Here's how to init the UART peripheral and how to send characters and things like that. Really great basic stuff. And I like that this is MIT licensed. It's very permissively licensed, so I don't have to worry about like if I ever do CircuitPython, then I can kind of start with this. So I was starting to think more about, let's see. Yeah, so Ryan G points out that the Pi 4's USB to OTG is brought out to the USB-C, so it can be both a host and a device. That's true. So the Pi 4 is actually very interesting for that. The one kind of bummer about it is that because it's also the power cable, you have to make sure that like either the host you're connecting to, or having a hub in the middle to make sure you have enough power for the Pi 4. But yeah, the Pi 4 B plus should be able to do it too, just not on the hub like side of it. The A's, it would be on the USB-C. So what's cool about this is that it like covers the tool chain. It covers how to do the UART stuff. The mailboxes is like the mechanism that you talk to the GPU. The Raspberry Pi is really weird because it's like, and I didn't fully appreciate this until I did these tutorials this weekend, but the Raspberry Pi is really just a GPU primarily. Like it's an HDMI machine first and foremost. The number of peripherals that it has besides like the GPU is actually quite small. So like I think it's like 2 SPI devices and 2 I2Cs, like very limited PWM. But it also has like 2 or 4 Cortex A's cores. So that's really interesting as well. But I thought it was really impressive that it just takes like till like lesson 9 where you're actually like doing frame buffer stuff. So like it's actually very, very easy to get HDMI output because like the GPU starts you up and then it calls the core, and then the core can just say, here's a frame buffer, show it on the HDMI output. Which, as if you followed me before, you know that's really why I'm interested in it. Is that I think HDMI Adafruit's role is, in my opinion, bringing low cost, like bringing existing technologies to the low cost open source market. So like, um, there's some technology in your computer or in your phone that like is hard to get a hold of, and not well documented. Like Adafruit's role and value add is that like we take those things and we make them simpler and more accessible and lower cost. So I think, um, TV access and getting things to show on TVs is like already kind of satisfied by Linux on the Raspberry Pi, but I always have trouble with Linux on the Raspberry Pi. So I would love to have the simpler life of CircuitPython and just plug it in. It shows up as a drive. Um, so I want this has some core things to it. It has the frame buffer stuff, which I am really interested in. It has reading the SD card, which is really interesting, right? Like we still need to be able to store stuff back to it. There's a couple things like they cover UART, but they don't cover I2C or SPI. I'm sure I can find examples though. But the other thing that is not clear to me here, and maybe actually that's what this is, but how interrupts occur is different on Cortex A's, and I was reading about it I think here, but also reading it about it more generally just for Cortex A's. But there's in the Cortex A series they have like execution levels and then there's exceptions, and so the way that like whereas a Cortex M has like an NVIC, which is like a nested vector interrupt controller, like that thing doesn't exist on Cortex A's. Instead, what they do is there's just like a more general exception system, which is like communicating between different levels of execution, I think. And then like there's like one type of exception that means an interrupt happened. And then like, so that will get you running code. And then you have to decide like which of the interrupts to do. So I think there is a world where you could basically write C code that acts like an NVIC, but on a Cortex A. So I think that's the biggest unknown when it comes to thinking about getting Raspberry Pi support generally in CircuitPython. And I think the first step, and the step that maybe I'll try to poke at this weekend if I have some time, although I kind of want to go for a hike, is doing oh yeah, that's a better e-ink example on my disk. Doing tiny USB support. So adding Raspberry Pi support to tiny USB, primarily just in the board support and the examples. The USB peripheral on the USB peripheral in the Raspberry Pi is actually one we already support. It's a very common one that's sold by like a third-party vendor and like is in the STM series and some other chipsets already. So like we already support it in tiny USB. It's just a question of like how do we hook it into the mechanics and get it running. So it should be pretty doable. It's just like how do you like what's the interrupt handler look like and stuff like that. So once we had tiny USB support, we get the example running there. Then we can start building it into CircuitPython, and we have to get like the storage working. And once we have storage working, we'll basically have the drive and the serial output all working. And then it's just a question of like then we would do like implement display IO for HDMI output, implement SPI, I2C, and UART for bus IO. For the like weirder ones where we need different peripherals, we might actually have to move to this model. Like we'll actually just use another core to do like rotary IO or something. I don't know. If we wanted to be really broad, but I think like there's a lot you can do with just display IO and bus IO. So yeah, Pavre 6, does that kind of answer your question or sound interesting? Foamy Guy says, as an alternative approach, do you have any thoughts on using something like Blinka Display IO with Pygame output instead of screens on IO pins? I'm not sure what you're talking. I don't know exactly what you're meaning. Are you just are you just saying like instead of doing bare metal CircuitPython? Um, Hi Rabahi on YouTube. Foamy guy is typing. All right, what's next on the list? Or in addition to, just as a way to get display I/O into HDMI. Yeah. Yeah, I mean, I think it makes sense to also support display I/O out the HDMI link through Linux. But like I said, I kind of not a huge Linux fan. I use Linux for my desktop now, and I feel like I'm pretty constantly burned by the USB stack not being very happy. So I like to think that I could live a simpler life, which is probably not true. And I think that's the danger of doing CircuitPython on the Raspberry Pi, is that once we have CircuitPython bare metal on the Raspberry Pi, people will just continue to ask us to be able to do things that they can do with regular Python on Linux. Like Bluetooth and Wi-Fi support, for example, are like, do we really want to re-implement that on bare metal CircuitPython on Raspberry Pi? I don't know. Maybe that's what's the point where we just say use Linux on it instead? Yeah. Also for HDMI output, we've looked at a bit. There are some converters that can take a 24-bit RGB pixel stream and produce HDMI. But most of those that I've looked at don't do audio over HDMI as well, which I think we could do with Raspberry Pi, which I think would be nice. Nice. Foamy Guy says, I may poke around on that front. I'm getting more familiar with Linux, though not on the Pi, really. Yeah, I think having a Pygame output for display I/O would be cool. I think there is a world where Linux is the right way to go. And I think that world is when you need a lot of things running all at once, for example. I like the idea that CircuitPython is about doing one job, even if that job might do networking, which might be concurrent under the hood, or asynchronous under the hood. Okay. Let's see. 3243. So Grayscale support's checked in. I mentioned it already, but I did just look down. I got a couple Adafruit packages this week, and one of the things that I got is this. We're currently calling it the e-ink portal, which is the same 2.9 as the Featherwing that I showed earlier. It's got 4 side-lit RGB LEDs and then 4 buttons on the bottom. It's an ESP32-S2 with apparently the canister removed on this one. And then the big white spot is a spot for a battery. The goal, I think, being that you could actually stick this on your fridge and it would last at least a week, ideally, on battery power, and just show you whatever you have it showing. So, yeah, that's what the Grayscale looks like. It is interesting because Lamore tried it and tested it, and the Grayscale on Arduino is not the same as the Grayscale on CircuitPython for some reason, which we haven't debugged. But apparently there's some configuration setting we're doing differently, even though we looked at the code and we think it's the same, which is weird. Yeah, so the IL0373 library has been updated, and the updates it needs in the core are in 6.1, which is currently just main. I think Johnny wants to know about 6.0, probably. Okay. So Hugo says, what is meant by Grayscale is not the same on Arduino and CPython and CircuitPython. Let me find the issue. I might have to look at my email. There is an issue with Bonhomme 2 says, my local supermarket is full of these e-ink displays to display prices. Really annoying when they all start blinking that their battery is low. Yeah, that's like why they're so prevalent and cheap, is that because they're used for for price tags. I'm searching my email down at the bottom here. If anybody knows, I think it's on the image reader library. It's a very interesting topic here. Yes, here we go. This issue here. So if you don't know Phil B, and did I take a time code that I should undo? Nope. I'll talk about 6.0 in just a bit. So Phil Paint Your Dragon is Phil B, who has worked for Adafruit for a while, and is kind of like, I think, the father of the NeoPixel. So if you've ever seen like all the animated eyes, like Phil B does that. He does he's been doing some gamma corrected stuff for the RGB matrix stuff. He's very much a graphics guy. So I saw this issue, and it's really interesting because he made this test image that's just black to white, ramping up, and then compared to how it looks on the Arduino code on the feather wing. And one thing that's really interesting is to see where the bands change, right? So like if you were thinking about it, basically you would expect like even quarters to be one of the 4 colors, but that's not the case on Arduino. And Lamore thought it was just an issue here, and then I thought, oh, let me try this on CircuitPython. So here's the picture that I took. Yeah, Bonham2 says that is why PlayStation uses dithering to solve this problem. Yeah, so there's another thing to think about though, and so here you can see that we tend to like not do the highest color, and also is it, oh, it's not on here, but if you look at this light gray, it varies a lot between CircuitPython and Arduino, and we're not sure why. She must have emailed me. Lamore had a comparison between the two, but basically like we get 4 grays in both Arduino and CircuitPython, but they're different. Like the middle 2 grays are different. And I think the way the grays work is that like the what you're doing is you're toggling the voltages to get like bubbles of black ink to go to different places, and it's all about like how long you have those voltages and how long it takes the inks to travel. And so you get gray by just like doing it for a shorter time, so you get fewer black black bubbles kind of at the surface. Higo says, oh wow, that's a pretty interesting contrast between the two. Yeah, and we haven't actually figured it out. Like I think we actually need to like Salier logic analyzer capture what the communication between Arduino and CircuitPython is to the display. I do like this lighter gray. Like you can kind of see it in here, where the like belly of Blinka should be a bit lighter than it is. But like you're still getting 4 shades of gray, so it's not like a huge issue. But then the other question is like, how do you actually do these cutoffs? Do you do them on every quarter or not? And there's a great, I think it's on Wikipedia. HSL, HSV. I think this is here. Maybe not. But it's like the color theory and different ways of doing it. So there's HSL, which is hue. So that's like orange versus yellow versus red. Saturation is like white or gray to fully that color. And then lightness is like between dark, like black and white. So there's different ways of thinking about it. And then We were talking about this last week, weren't we? But there's hue and chroma. Where is the... There was a great example of... Yes, this. So, what we were talking about last week is this notion of how do you produce a black and white or grayscale image based on a source image. And this is what I was really looking at, is that here's what the photograph looks like, and what kind of curve, or how do you treat, or how do you compute what the brightness is of something, and what sort of image results as an artifact of that. And so you can see here, like, all the different versions of this are based on different computations for, like, intensity. And I think that's what you're seeing come out in this thing here, is that we reserve this, like, very white side for, like, just the like true highlights of the image. I think I followed the formula for this, but I'm not positive. But this is kind of like what I was going with the Luma stuff in CircuitPython. So I think that's why that's why with this gradient you don't just see like quarters for it. So I think it's right. I'm not too worried about it. So if you take an image and plop it on there, let me know how it looks. And we do have auto dithering as well. Somebody added it to the color converter. So there's an option when you construct color converter to have it dither, and all it does is it randomizes colors within a little bit. And that means that, like, in this case where you have a gradient left to right, all of the pixels in one vertical row will actually be shifted a bit from each other, which will kind of use the colors to dither it and make it look a little bit smoother, which is neat. All right, so any questions about that before I move on? I don't see any. Okay, so let's do a 6.0 update. So that code got checked into main, and main is like our main branch. I don't think that's there. Hugo Dahl says, thanks for that detailed explanation. Makes sense now. Bahamut says, JP did some amazing costumes for the other day for Rocky Horror. Yes. If you haven't watched the Adabox unboxing from Wednesday, JP did an amazing job dressing up and getting into character for the unboxing for Adabox. So check that out if you missed it. It was very entertaining and I enjoyed it a lot. I think he didn't stream yesterday because he took the day off. He certainly earned it. Okay, so let's talk releases. So where we are right now is, let's see if we just look at the downloads page, I guess. So where we are right now is 5.3.1 is stable. 6.0 RC0 is released. We've made fixes to, so 6.0 RC0 was both on main, and we also started like a branch off that for the 6.0.x branch. David says, interplug for Adafruit giving employees the day off to vote here. Yes! Adafruit gives the day off on Tuesday for employees to vote, although in most places people can vote early, so they should do that too. So if you're in the US and have not voted, please do. I've already voted. I voted last week or something. A couple days after. We get ballots mailed to us, so I think I mentioned that last week. So our 6.0 releases are now coming off the 6.0.x branch. And if we just look at the commit history, we can see kind of where we're at. So there's a matrix portal fix. We had this board spy from Christian fix, fixing losing like board.spy and board.i2c. We had Microlab fix. We had a Circuit Playground Bluefruit spy fix from Jerry. And I think that's about it. And then we go back to the like what main has. So we only have a few fixes, but that means it's different than RC0. So the plan is that there is one outstanding, I think one or two outstanding issues. If we go to milestones and do 6.0, we can see that there's this board spy lost after being used by display, which is actually fixed, but things don't get fixed until they're merged into main. And the way that we do it is if we want to fix it for 6.0, we merge it into 6.0x, and then we merge 6.0x back into main as we kind of add stuff there. And then there's this other issue with REPL access that we marked as a 6.0 issue as well. And Dan just confirmed today in the last thing here that it is an issue with how USB handles. Let me thumbs up that. It's an issue with how our tiny USB code handles when the host computer goes to sleep. So the USB device, like USB actually stays active when the host goes to sleep because it could be like a keyboard or a mouse that you actually want to wake up the host computer with. But we had this bug where we lose the serial REPL. Like it doesn't work quite right. So Dan's finished up the ESP32 as a BLE coprocessor stuff. Did a really nice guide on that, and so he's kind of taking the 6.0 stuff back over from me. He's looking into this one last issue. Then what we should do, what you should expect to see, is an RC1, and then hopefully there's no issues with RC1 in a week or so, and then we'll mark that as 6.0, which I'm very eager to do. And the reason I'm eager to do that is I'd actually like to start releasing 6.1 pre-releases because we have the separate branch from 6.0x. It means that we're not actually releasing the absolute newest things like the grayscale support in any like numbered version. So I talked to Dan yesterday. He's going to kind of focus on that and then start. He's also doing ESP32, starting to ramp up on ESP32-S2. So I think I was thinking about this yesterday as Dan and I were talking, but we do get to this point with ports where it's like, we kind of have the broad coverage of the API that we want, but we just haven't used it a lot. So there's like all these corner cases that still exist, and bugs that happen. So we're kind of going all hands on deck with the S2 to have like a number of us Adafruit supported developers working daily on S2 and really like kind of hammering it, like just testing it, right? So like using it, and when we find issues that we think are like not the way it's supposed to work, then we have the freedom to run those issues down and really refine them. So it's exciting times, especially if you're here for the ESP32-S2. Is it like we're, to some degree, I would say, in the home stretch of moving the S2 support from the like beta column to the stable column, which will not actually happen with 6.0. It will happen 6.1, 6.2, 6.3, depending on timing. Professor Sparkle says, I find that that always takes the longest, really, finding all these odd bugs and edge cases of peripherals. Yeah, true. Oh, and I should shout out Microdev. What about the modules package? I don't know what you mean by the modules package, Neradoc. But we should give a huge props to Microdev, who's has two pending draft PRs, one for rotary IO, which is used for rotary encoder support, and one for count IO, which I don't actually know what it's used. It was like a kind of like community contributed module, but it just counts pulses over time. Neradoc says, I mean the libraries. The libraries package. So all of the libraries in the bundle should work on the ESP32-S2. Do you mean... Yeah, I don't know what you mean. Like, libraries should just work, and if you find issues with it, you should let us know. There's certainly, like, more requests side work to do, and we'll talk about that. But generally, like, I2C drivers and stuff like that should just work. And I think Bruce S. tested it for me. Like, displays do work now, too. I think was it last week I talked about that fix? Maybe I didn't. Did I talk about the fix for SPI? Professor Sparkle says, I always had this idea of CI/CD on the electronics level and then run automated unit tests with actual devices to help with such work and find regressions. Yeah. Let's take a time code and let's talk about that. Because it is interesting. 5058. Yes, so this is something that I was like pretty keen on pretty early on. And we had this system called Rosie. Is a system that I put together that is like a CI for hardware where you basically like have a bunch of like Adafruit devices hanging off a Raspberry Pi. And then the Raspberry Pi gets called through ngrok from GitHub Actions or Travis even. But so this is like my first attempt at this. And the problem really was that I was loading the code over. Ooh. Mr. Certainly says, oh, regression testing. Now that's my cup of tea from back in the day. And then Bruce S. says you might have mentioned there was a problem. Yeah, so the way that this worked was it would do the trick in CircuitPython to kick back to the bootloader and then load the new version of CircuitPython. So it was not super reliable because if you messed up that loop or like the USB stack on Linux failed, like you would have a bad time. So yeah, that was unfortunate. I used it for a while, but the reality was that it was like not reliable enough to block anything off of it. And then Summersoft was really into this stuff too. So I think it's called RosiePi. Dan's thoughts. So Summersoft was working on this too. Who's been a huge help. Oh, this is why it's linking. Automated physical testing for core contributions. I hope to get RosiePi in a state where a node is easy to set up for whoever wants to host one. No links, though, unfortunately. GitHub.com/Summersoft. Hi, Alvaro. PhysiciCI, thank you. So, yeah. Let me copy that. Thank you, Foamy Guy. So, here we see, this is like the more modern stuff. Like, it's something that Summersoft has been plugging away with. So, if you're curious about it, there's a place to go and take a look at. You can ask Summersoft about the details. We're not relying on this at the moment, but that's another project that's kind of geared towards the same thing. And then the last thing I can think of is actually there's this new startup called LoggerData, loggerdata.com. Professor Sparkle says, I was just using the GitLab CI to automatically compile and upload a huge amount of Metro M0s. It was working very well. Nice. Yeah, so we already do compile, and we do compile for every board already. So the artifact side we have covered. What we don't have covered is the like how do you get it on the device, and then once you do that, how do you test that device? Yeah, but you really need a solution to deal with a huge amount of devices to automatically connect to a board. Yeah, so there's this startup called Logger Data, uh, who the CEO is Akbar, and I actually pitched. I had a meeting with Akbar because Logger Data works with somebody who I know. I got connected to them, and I was like pitching to them like, hey, you're early on. You have this system. We're like clearly an open source project that would benefit from a system like this. Like, it would be amazing if you would use us as your like canonical example of like how the system works, and use it to sell it to other people that it works really well. So I pitched that to Akbar, and he was gonna take a look at it and run it by some people and then get back to me. So hopefully we'll hear that they want to do that. I should probably email him again and see, but yeah, it seems to me that like we were definitely like an example of like the style of customer they were going for. Um, and it's interesting too because they're a business, right? So like potentially, in the same way that GitHub has a free tier for open source projects, like maybe that would be their model as well. Which I think is a really good model because like then you can demonstrate a working system for people. So yeah, we'll see how that goes. That's another thing to check out if you're curious. Okay, let's keep moving. What is it that they do? They do both the server side. I don't know how much I can say. But they had a similar system where they had like Pi Hat connected to a Raspberry Pi that would like control a device that they would test, and they have a dashboard and stuff that you can hook up to. Hey Charles. They do very similar to what we're talking about, is like connecting the device all the way to the like cloud CI side. But yeah, they're definitely early. I don't think the business is more than like 6 months old, something like that. But they do have some funding. So yeah, if you're more curious, I'm sure they'd love to talk to folks who could use that, be their customers in the future. David links to the blog. Yeah, first post was July 27th, 2020. Yeah, so they're very new. It was interesting because I had to think about it. I was like, oh, like we're an older project and potentially larger project than this new company. And Adafruit certainly is a good voice too. So I was like, we probably can't pay you, but we'd love to, yeah. We like, if we end up using it, we're happy to say we use it. And Professor Sparkle points out I'm more interested in open source platform, but sure. Yeah, if you want an open source platform, the thing that I know of the most is the work that Summersoft has done with PhysaCI. So check that stuff out. I don't really care who does it. Like, I would just love to see it done. It's one of those things that's just so hard for us to prioritize working on, even though it's like very much a long-term benefit. In the same way that like finally having some basic unit tests for like the request library is really good. Okay. Do we want to talk sleep? Let's talk sleep for just a bit. So I did like finally get myself in a state to like have a focused few hours on Tuesday to work on it. So I started. Yeah. So here's the changes I made. And I was really kind of. I realized that a lot of the work that I needed to do for sleep is really dependent on having access to the reset cause, which is like the reason the microcontroller started in the first place. And then also the reason why the VM is running again. Johnny says, thank you for the 6.0 update. You're welcome. I know people are excited about it, but it's just like, it's an interesting problem. Maybe I could get derailed again too, but when you're running an open source project, how do you move from this development model of just check into main and we release it frequently, but like maybe we call it pre-release, to like having a separate branch where most people are still working in main, but how do you get a few people to go to the like branch and like refine it enough to be called stable? It's a really interesting question in and of itself. So for example, the Linux kernel has this like inverted model where most of the time individual groups are working on their own thing, and then there's a merge window that opens. So if you want to get in like Linux 5.10, there's like, I don't know, a few weeks where you like Linux will merge into mainline, the mainline kernel, and then after that it just stabilizes. Whereas like we're the opposite, right? Like our main is mostly open all the time, and that's where we work. There's this interesting discussion happening where like I'm on the Zephyr TSC, the Technical Steering Committee, and they're having this great debate about like what they do is they don't have a branch. They only branch after the stable release in case there's fixes to the stable release afterwards, and then they have a merge or like a release freeze window. So like 3 weeks out of every 3 months is like you can't commit to main because they're trying to force everyone to fix the bugs in main so that it can be released to stable. But then there's also discussions about like, well, can we create a branch where people can work on the side while that release freeze is happening? So there's an interesting debate there about like, if your regular workflow is just continually moving forwards, how do you rally everyone to get the bugs fixed? So yeah, it's interesting. Like right now we can't release a 6.1 pre-release until 6.0 goes out the door. So that's kind of like our way to have that forcing function of like, oh, you want to actually get the stuff you checked into main released? Well, we need help fixing this bug or that bug. Anyway, that's a detour, but is like meta open source project stuff. Like how do you organize things? So if you have experience or opinions on that, I'd love to hear them. Okay, back to sleep. So I was starting to play around with this idea of thinking about what the CircuitPython workflow is in a world where we try to preserve battery when your code's not running. And so like, and it comes across as this deep sleep feature, right? So there's a lot of things to think about. One is like, and microdev thought of this, is you don't want to, so the deep sleep disconnects USB. So you don't want to deep sleep immediately before your computer has a chance to start up the USB connection if you are actually connected, right? Because if you are connected to USB, we want you to be able to access the drive and see the serial output. So one thing is like, if you plug it in, you start up, and your code.py finishes really quickly after setting deep sleep stuff. One is that like for the first 5 seconds or 10 seconds, we just don't want to deep sleep because we want to give a chance for USB enumeration to happen. And so that's what kind of I'm trying to accomplish here. And it doesn't compile or anything, but it's something that I'm starting to play with and need to get back to next week. But this is kind of what I'm thinking about. I had this discussion with Lady Ada. She was like, I tried deep sleep on Arduino and it was really simple. I just called this method and then it like poof, everything disappears and you're in deep sleep mode. And I was like, yeah, that's great. But like, there's a lot to consider about when to call that and when not to call that. So I think the way that we want it to work, and have I talked about this? Am I covering territory? I don't think so. I think I have a better thought process for it now, but it's basically for the first 10 seconds after you get like power, like you don't want to deep sleep. And then after that, if you are enumerated on USB, you don't want a deep sleep because that would disconnect USB. But you want to act to the CircuitPython code that's running as if you did deep sleep. So if you're actually writing code where you're trying to test deep sleep and you're on USB, like it should act the same way minus actually deep sleeping, if that makes sense. So if your code runs, you set some alarms and then it ends, we should light sleep and wake up based on those alarms. And then the state that we present to the Python VM again is the same as if it had actually deep sleeped. And then, so it's fake sleeping. Yeah, kind of. I was debating calling light sleep napping. Like there's sleep and nap. Nap would be like light sleep. And one of the challenges of that state that I haven't fully worked out is there are other reasons that you'll wake up in light sleep. So like if USB is happening, like the sleep that we do right now will still wake up if like something on USB happens. So we actually need to, the code will wake up and say, Neradoc says it's just resting its eyes. Benjamin says, how do you foresee to wake up from deep sleep? So the things that I'm targeting for wake up for deep sleep, I think I just want to start with two ways of waking up from deep sleep. One is pin level, and the other is by time. So alarm-based, time-based alarms will be exact times. They will not be relative times. Dylan says it just needs a small latte sleep. Yeah. So the way that I'm thinking is that like your code.py runs, you set alarms that you want to wake you up. And that could be like waking me up at 10:15 or waking me up if this pin goes low. And then if you're on USB and you exit cleanly from the code, what it will light sleep and then wake up from that alarm and rerun your code as if it was coming out of a deep sleep on USB. If you're not on USB, it actually will set those alarms and go into deep sleep, and then the whole CircuitPython mechanics get restarted. And your code.py runs again like it started up from deep sleep. But there's this other weird case that you have to think about, which is what if your code crashes? So what do you do again across that? Like I'm on USB, I'm on USB, enumerated USB versus I'm on just battery. Like what do you do when you crash? So your code.py starts up, you do a Wi-Fi, you connect to Wi-Fi, and then you do a request, but the request causes a crash. What happens then? And like there's a couple things I could imagine you would want to do. One is just like either run again or set your deep sleep alarms before you do that, and like they still apply so that you'll like go into deep sleep and run again. Or like we should probably also think about Hugo Dahl says, what about not writing code that crashes? All my code crashes, so I'm not willing to make that assumption. Like you don't want it to like consistently crash and not demonstrate to you that it's been crashing. So one thing we'll do now is like after your code finishes, we do this LED blink sequence when it crashes, or just like a green ramp up and down. But like we got to stop doing that for deep sleep because LEDs are like power costly. So what I'm thinking, and tell me if you like this theory, but I think what we'll do is if your code crashes, I think what we should do is we should blink LED, like blink the pattern once, light sleep. We could light sleep for 10 minutes, or maybe what we do is we just blink the pattern once and then deep sleep until again, and then blink the pattern. So we'll definitely blink the pattern at the end. But I was also thinking maybe what we do is we blink the pattern, light sleep for 10 minutes. Mr. Certainly says call it catnap. I like that name. That I mean that's kind of what you're doing. Like you want to sleep really like all day long, except for when exciting things happen, like you get fed. um, the other thing I was thinking about is like, what if we blink and then we light sleep for 10 minutes and blink again, and light sleep for 10 minutes and blink again. But maybe that's not right because you don't want like if it crashes once, you probably don't want it to. Like you don't want it. Light sleep will burn more battery, and so you don't necessarily want that. So Benjamin asks, pin would include touchpad function of ESP32-S2. No, I know that Microdev has already started working on the touchpad stuff, but I just want to like, there's enough to think about with this that I really want to narrow it down. And with my API design, my hope is that it's easy to add other alarms. So like what I would expect is that the very first version, I just want to do time and pin because those are like super common. But then I would expect like a touch alarm to come like very quickly after that. So not in like I'm trying to narrow my focus because I've been like so distracted anyway that I like really need to reduce the amount of work I need to get it in. Because there's like these core questions of like what is the workflow with and how does sleep impact the workflow, that like we have to answer those questions first, and then like once we have this notion of an alarm, we can have other types of alarms. So like the thing with alarms is that when you create an alarm, it should tell you whether it's feasible. But then when you there's two things you can do with an alarm. You can give it to a function that does light sleep and like maintains your Python code. And like at that point, it should evaluate all the alarms you gave it and make sure that like all of them can coexist. And then there's also the like, let me set alarms for deep sleep. And again, that should make sure that they all coexist. And those two individuals should also verify that the alarms can work in the sleep mode that you ask them to work in. So there's like two levels of verification. There's the, I want to set a pin alarm on this pin. Can I do it at all? And then there's the, I have these 5 pin alarms. Can I do them all at the same time? And Johnny says that's where unit tests come in, right? Even with unit tests, I would not assume that your code's perfect and that it may crash from time to time. Charles says, all code might crash if somebody hits Control-C and the code does not catch it. Yep. Yeah, but then you're on USB, you're not deep sleeping. And Bonhomme says, well, hardware never runs like it's supposed to. Dealing with that is one of the biggest things drivers, kernels, firmware have to deal with. Yeah, true. And networking is like, oh my gosh, like doing networking stuff is like you're talking to a computer that might do whatever it wants. Like there's lots of crashing that you have to deal with like the notion that a TCP connection can disappear at any time. It's like it's a lot of error handling, even more than I think like hardware has. Yeah, so if you want to check out my sleepio branch, you can see that I just started sketching out the changes. I haven't compiled it at all. You can see I deleted the alarm touch stuff that Microdev had started, just because I want to like really narrow down my focus on like the core of deep sleep. So yeah, like I've been saying for the last like 4 weeks, this is like what I want to work on. But I've been distracted, and let's talk about the things that have been distracting me. I think, again, they're good things to be distracted by, and they're all kind of like, if you haven't realized it, they're like very much like my work is gearing towards the like e-ink portal, like because it's a device that like we want networking, we want on the S2, and we want it battery powered. Like all of these things are going towards that goal. So if I get distracted, it's not the end of the world. David says, speaking of unit tests, I just saw a note about to get extremely good code, the return on investment of unit tests is not good. I wouldn't say that. I think unit tests are very valuable. I think my hang up has been just like testing on hardware is really, really hard. And that's where I feel like we would get a lot of our value. Benjamin says, sounds cool. Happy with the Feather S2. I'm planning to update it tomorrow. Awesome. I didn't want to break it before I had some of my scripts running. Yeah, get it started with what you got. I should also say this, like, for this crowd that's like a lot of ESP32-S2 folks, I don't expect you to use the 6.0 stable releases. I would encourage anybody interested in the S2 to continue using pre-releases, because like there's so much going on in the S2 port right now that like you really want to be like very close to where we're at. And if you didn't know, actually I should just show this. If you want, there's this absolute newest box, and if you hit that, here's where you get these are all the old files. You can ignore all that unless you really want like CircuitPython 0.9.6. I mean, it's cool that we have all that history. You can see 2017 builds. But if you want the absolute latest, pick your language here. Like I'll pick ENUS, and then it lists this big bucket of basically all the builds. So they have the date of the build and then the hash of the GitHub commit that they were from. Right now, where we have like two branches, I think both the 6.0 and the like 6.1 mainline stuff will go in here. So you might want to double check that the commit's on the right branch. But generally, I would encourage you to just like pick the latest one and see if that works best for you. And as you can see, you also get tags in here. So I actually did a 6.10 alpha 0 tag already. And that's so that any build from main will have that as like the tag on it. It won't say 6.0 RC0 on it. But you can snag that from here as well. So that's how you, like, if you really want to be on the latest thing that's checked in, this is where you can go for that. Professor Sparkle says, I would say it depends. If your application has a short lifetime, writing unit tests might indeed not be worth the investment, but anything that is long-lived can benefit over the long term. Yeah, that's a good point. If you're just going to use it for a demo for 2 days, then you don't really need the unit tests. But if you have components that you reuse in demos, then it would be good to test those components. Okay. Let's talk polish. We're only an hour and 15 minutes into this thing. Okay, so if you've been using the ESP32 SPI stuff or the S2 stuff, you've been using requests 1.7, and requests 1.7 should have been requests 2.0. Which Melissa pointed out to me is like, you changed a lot of stuff. We probably should have just called it 2.0. And I agree with her. We should have done that. But I was really trying not to break anything, which is why I didn't actually call it 2.0. But numbers are free. Next time, just go with 2.0. That's the way to go. But we've been having some issues crop up, including this pretty broad one of like, get doesn't work. And Melissa, Lady Ada, and I started taking a look at this yesterday. And there's a couple issues that we fixed. Carstring88 says, if you're creating APIs, others will consume. Unit tests are really helpful. Yeah, that's true too. And it gives people a demo, like an example of how to use it. Like Adafruit's really good about having examples, right? Like that's what learn guides are. But they don't automatically get rerun every change, which is the part that would be cool. So, hi, Dave. So we started running down these issues, and the first issue that I wanted to talk about, and you've probably seen it on the S2 with, so Benjamin's, yeah, this is our version of requests. So it's not actually Python requests, but it's like a stripped down version meant to run on CircuitPython in like a very limited capacity. The API is mostly the same, almost exactly the same. We have like the get post sorts of APIs here, and we have what I added. One of the things I added was this notion of a session, but the arguments to the session are different than Python requests. So one of the challenging things with networking on the ESP32-S2 and in CircuitPython generally is that like we don't have an OS. And CPython themselves, they delegate to the OS to manage networking. And that's kind of the approach that MicroPython took, where you like kind of like install, like you create some Python driver and you install it, and then like it crops back up through the standard CPython APIs. And I didn't really like that because like those two things kind of like don't connect very well together. And so what I wanted to move us towards is and most of our networking support is fully implemented on the Python side and is not done on the native C side. So what I wanted to do is move us to a model where stuff that does networking takes in a socket pool, which is what I decided to call it. And the idea is that it's just like something that can give you a socket. So in CPython land, that's the socket module. The socket module is this socket pool. Wrench, I have no idea what's going on. We're talking about networking APIs. Benjamin says, so I believe that this is not included in the UF2 you mentioned earlier. I need to figure out how to get that on my Feather S2. Yeah, sounds like you're new to CircuitPython. The best way to get that is that we have what we call the bundle. The bundle. And it's an automated like meta repo of all of the CircuitPython libraries. So it gets released once a day if something's changed. So what you do is you can go to Adafruit CircuitPython bundle. We automatically tell you what libraries have been updated. We thank the folks that we think had something to do with that. This is all automated. And then we produce these zip files. The MPY versions are just like a bytecode version of a Python file. They're great if you're limited in memory because they reduce the peak memory usage of importing during import. It doesn't change, or it only slightly changes like the actual like memory footprint of the module. But if you have a lot of space or a lot of RAM like you do on the S2, I would suggest just downloading the Python bundle because that'll get you actually the source code. So you can download it, and then if we look in the contents here, there's two top level folders. There's a lib, which has all of the packages and modules here. So if you wanted like Adafruit requests, it's just right here as Adafruit requests. So you would unzip this and then drag it over to your CircuitPy drive, and now you've got that library. You might find that when you import that, it needs another library, so you would just go here and drag that over as well. And then all the libraries have examples, and we merge those examples into one top level folder as well, and they're prefixed with the library name. So if you wanted to see the requests examples, you would go down here and you can see we have advanced cellular, CPython, simple tests, that sort of stuff, all in this bundle. So if you need a library, our workflow is very like drag and drop oriented. So that's why we have this bundle model of just like, you can get all the libraries every day bundled up together. So yeah, that's how you get libraries on CircuitPython. There is a cool tool called Circup, that can actually look at your drive and update them for you. All of the library files, when they're built, they have this like placeholder for the version and the repo that they came from. All the files have that. They should. And so Circup can look at your drive, see what files and where they came from, and then offer to like update them, which I don't actually use, but I know people continue to fix it, so I think other people do use it. But yeah, it's good to go back to basics on CircuitPython because we're constantly having new people come in, which is what we want. So I had a question from David G says, so will we be able to write server that can listen to connections like a web server? It's not implemented now, but the goal is to have that. On the CPython socket API, there's bind and accept is kind of how you get sockets from a TCP server. They are not implemented yet, but that's what you would need to be able to do a basic server. David says, what my FeatherS2 will be able to not use the MPY and to copy every library, or should I continue to cherry pick? Yeah, so David points out that because the flash on the FeatherS2 is so large, you can actually probably copy the whole lib folder from the bundle over, and then you'll just have everything. If you want to do that, that's totally cool. But like generally we've had to stop recommending that because a lot of the boards can't fit it. Like we have a lot of boards that are 2 megabyte file systems, and those are too small to hold all of the libraries in the bundle at this point. So, well, I think we'll continue to encourage people to cherry pick the individual things over. But if you want to do them all, go wild. Tabat says, what is the time frame for IO MQTT getting updated for requests? I don't know the guts of the MQTT library, so you would have to ask Brent. Jack asks, what is Adafruit? This was on my recommended, so it must be about coding. Yeah, it is about coding. Although I don't tend to... I have a little code I'm hoping to do today, but generally I'm answering coding questions. Adafruit is an open source hardware and software company based out of New York City, and I work remotely for them on CircuitPython, which is a version of Python for hardware. I can show you pictures. So if you go to circuitpython.org/downloads, you can see all the different devices that CircuitPython will run on. And generally, the way it works is that if the device doesn't have CircuitPython by default, you can double tap the reset button. It will give you a drive on your computer that ends with boot. You can copy a UF2 file for CircuitPython over, and then it will restart, and you'll get a new drive that says CircuitPy. And on that CircuitPy drive, you can put a code.py file, and that's a Python file that runs every time you save it. So you can iterate really, really quickly on the Python code. And that Python is like the mechanics to run that Python file are all contained on the device itself. So if you are writing some code to blink an LED or something and you're connected to your computer, you get it working the way you want, and then you can plug it in with a battery later, and it will still run. Yeah, and Jack says, I'm used to the microbit. Thanks for answering my question. Yeah, so exactly like microbit level stuff. The microbit has MicroPython on it, which is CircuitPython is based on. And the microbit 2 came out, and it will also have MicroPython on it. I'd love to get CircuitPython on it, but it unfortunately does not connect the native USB to the USB connector, which is unfortunate. But yeah, if you have embedded questions, like encode questions, we're happy to talk about them. That's kind of what, this is a deep dive, but we generally, it's just like me talking about stuff. And we'll take a look at some code. And Unexpected Maker points out that on the FeatherS2, you press reset and then boot to get into the UF2 bootloader, not double tap reset. If you have a version with the UF2 bootloader on it. Early boards that ship do not have the UF2 bootloader installed by default. And this is something we need to work on. Actually, maybe I should. I'm distracted away from the receive thing, but I haven't finished talking about that. But we should plug the UF2 stuff since we're talking about it. Hugo points out for Jack that the next board you may want to get after a microbit is this Clue. It's a microbit shaped board from Adafruit that includes a screen instead of the LEDs, and then the USB that's connected is native, so you'll get all these CircuitPython-y things. And it has more RAM and stuff too. So yeah, if you're used to the microbit, like this is totally, as Hugo points out, like a really good next board to start with. You'll be able to do more. The chip on the microbit itself is like not super powerful, so you'll be able to grow into it, which will be cool. Okay, so let's talk just a little bit about UF2 because UF2 is cool. So there is an Adafruit repo UF2 ESP32-S, and this is the UF2 support for the ESP32-S2, which Unexpected Maker has been adding some features to, which has been great. And if you wanted to get the UF2 bootloader onto your Feather S2 because it doesn't have it already, like this is the place to start. It's not super easy, but this is how you would do it. Ideally, later we'll have like a bin that you can just flash, but you can see here that like there's instructions on how to do it instead. But I want to highlight, and Jack, I'll answer your question in just a smidge. There's this new pull request as of yesterday, and Unexpected Maker, you should definitely take a look at this. But I've been really pushing. So TAC here is paid by Adafruit to work on Arduino and also like USB stuff. He's the author of Tiny USB, which is why his logo is the Tiny USB logo. But I've really been pushing TAC to create a unified UF2 bootloader repository. And so what he's done is he's taken the ESP32-S2 version and generalized it. So in this PR, he's added support for the IMX RT and for the STM32F4. So my goal or my hope going forwards is that as we have new platforms, like what we'll do is we'll just have a central repository to do it. So this came up with like Unexpected Maker having an APA 102 RGB LED on their board, and it didn't have we didn't have support in the bootloader for it, even though we have support for those things in the UF2 bootloader for the Atmel SAMD series, for example. So yeah, I got really frustrated by the fact of like we have that support here for UF2, but not for this UF2, and so I was really pushing TAC to like be like, we need one repository where we do all our bootloader stuff from. So he's been working really hard and migrating and merging this UF2 for the ESP32 stuff to be our general UF2 repository going forwards. So the goal would be is that I think it only has NeoPixel support still. It does have the single LED support, I think, added as well. But like once we add APA 102 support here, then like ideally it just works across all the stuff. So if anybody's interested in UF2, I think was it Johnny that said that they actually use it? Somebody said they actually have a fork of it that does encrypted stuff for their own boards, but like start here, check this out. TAC does really good work, but it would be good to get all of us kind of like my goal really is like Tiny USB has been really, really successful as a USB stack that's cross-platform. It was Johnny. Perfect. And what I would like to see is start to grow kind of like that Tiny family. Like I really like the idea of a Tiny UF2 bootloader. So like things that can be built in the same way or a similar way as Tiny USB. So I want to make it kind of a family of tools that are cross cross microcontroller family. The other thing I have in mind in this family is I'd really like to, and I mentioned this on the stream before, but I have a repo called Tiny Logic Friend, which is this idea of firmware for microcontrollers that can be used as a logic analyzer, very slow one, but it's also based on Tiny USB. And the idea is that just like all these boards that you see on the CircuitPython downloads page, like you could turn any of them into a low cost, like low performance logic analyzer. So if you need to debug like I2C, like you should be able to do that with whatever you've got. So still want to do that. Unexpected Maker says, good news is the latest order of the Feather S2 that Adafruit just received today has the UF2 bootloader already on it. So when those go in stock, you can buy those from Adafruit and you'll have the UF2 bootloader on there too. Bruce says, I took a brief look at putting the APA 102 stuff into the second level bootloader where it flashes purple. When it checks the button, decided it was not easy to get SPI working. Bummer. That's okay though. It's like relatively new to the double click that like you actually have a color to signify that you could do it. Oh, but Unexpected Maker says I do have it working poorly in the second stage bootloader too. Cool. Yeah, I'm excited to... Padre 6 says BIOS and bootloader, are they the same? I think generally yes. I don't actually know the term BIOS versus bootloader. I think some of it has to do with like the class of CPU. Like I would imagine that you get BIOS, like the term BIOS used more on a Cortex A series than you would on a bootloader, but I don't actually know. I don't know why one would use either term. I think they're generally the same. Like they're the first bits of code that start up. Hi, Generation. Thanks for stopping by. And it's good to see you too. It's always good to hang out with folks. Okay, let's pop off the stack. 334. Let's do more discussion about receive. So the issue that we had was right. Yeah, Bruce is talking about that the ESP32 is a bit weird. There's a ROM portion of the bootloader that then kicks over to a second stage bootloader. And then that can switch between the UF2 bootloader or CircuitPython. Professor Sparkle says, a BIOS is not really responsible for copying a new OS to the system drive via bus, while this is the primary function of a bootloader. David says, in the olden days, like CPM old, the BIOS remained active and provided some core I/O functionality. I don't think the bootloader is active after the app starts. Interesting. Yeah, we have a great crew of folks to fill us in. Okay, so one of the issues that we were seeing with requests 1.7 is that you would do the request and it'd be very slow. Like so slow that like it would take like a minute or more. And what we discovered when Melissa and Lady Ada and I were looking at it yesterday is we realized that the way we had implemented receive was wrong. And the best place I found it was so receive is this like function that comes like from like POSIX days. Like it's a very old kind of API. And the key to our problem was this phrase here, and I'll read it off because it might be too small for you. But it says, the receive calls normally return any data available up to the requested amount, rather than waiting for receipt of the full amount requested. So what receive does is you say, receive 10 bytes. And there's a timeout. And so what it will do is it will wait for a given amount of time before it says, I didn't receive anything. But what the ESP32 spy code is, and what the native receive of the S2 did is that it would receive the time, it would wait the timeout to fill up the whole amount of data that you wanted, not just for the first byte. And that was a problem because there happens to be a failure case, or not really a failure case, but a case in the new requests code where with the headers, as it's parsing headers, it grows. It has a 32-byte buffer, and there's this thing called read to. So it's basically you're saying, I want to read up until this sequence of characters, which for header parsing of HTTP is really handy because you could say, I want to read to like a colon space, which is like the end of a key of a header. And then I also want to read up to like a \n\r, which is like new line carriage return or whatever, which is the end of the line. And so you could say like, oh, I want to read up to that, take that and do something with it. And then I want to read up to that and do something with it. And I thought it was being pretty clever because what it used to be doing is like reading the whole line and then cutting it in two. But like that gives you one big string and then two smaller strings allocations. So I was trying to just do like one chunk and one chunk. But what I was doing is I was reading 32 bytes at a time and then searching in that for the things I was looking for. If you don't have it in there, though, you have to read more. So I have this way of like growing that buffer. And that's the buffer that I pass in to receive into, which dictates like the amount of stuff I'm trying to fetch from the socket. And what happened is that we found this failure case, or this case that was unaccounted for. It's not really a failure, but the Coinbase API in particular is particularly bad because it has this HTTP header where the key is pretty short, but the value is like 2,000 bytes long. So it's like some like list of domains for like cross origin stuff. So it's like this really long value, which means that that buffer that we're like searching in gets up to like 2,000 bytes long. And then once you grow that buffer for that really long value, and then to load the next bit, instead of loading just 32 bytes, we just load like, okay, we have a buffer for this much, we might as well try to load that much from the socket. But the problem is that like that means it's very likely that if we call receive, we're not going to get we're never ever going to fill up that buffer in receive, which means that you're always in the incorrect implementation. You're going to end up always waiting for the timeout before we return just like the smaller amount of that buffer. So what we were seeing is like people were saying like, oh, like it works, but it's just like really slow. And I had like written that off as like, yeah, like we are doing this like really like I changed the JSON parsing so that like as JSON's parsed, we'll read one character at a time rather than individual ones, or rather than like a big chunk and then parse it. And the reason to do individual characters at a time is that you don't do allocations for you never allocate the big long string. You only allocate like the strings you need after you've done the JSON parsing. And I was like, that could be slower. Like if you're doing this call to like, if you're repeatedly calling receive on a like tiny chunk, that could cause you to like do some more, like have a greater overhead there. Yeah, so we had this problem where we were hitting the timeout for receive. So the fix is, just gonna ban this person. So we have a fix in for the ESP32 spy that I did yesterday. And yeah, so if we want to just see what it is. So it's basically like in this while loop, while we have stuff left to read, if we have received something, then we break and we're done. So I have to do an equivalent fix in. I've done an equivalent fix in the S2. I've just got to polish it up. So that's one option. I should also note that if anybody had troubles with SPI on the S2, I've fixed that as well. Thanks to Ivan for that, pointed me to it. I was seeing this issues, and maybe I mentioned it last week with the Grayscale e-ink, where the first refresh worked, but subsequent ones didn't, and they transmitted zero. They transmitted the correct number of bytes, but the values were all zero. And Ivan pointed out to me that like there's a call that's not happening to turn off the transmission DMA. So I fixed that in, I think I fixed that here. But yeah, it should be fixed. Yeah, I don't know exactly where the fix is, but so if you were doing anything with SPI and you were seeing it not work, you should try it now because it probably will work. In this remaining time we have, do folks want to talk about UDP support, or do you want to talk about the receive PR, or do you want to talk about something else? But basically, I'm almost ready to do a PR to fix the receive stuff. And I also do change some IDF settings in that. So I just need to take a look at those changes, clean them up, and then I'll do a PR. Or I have some work to add UDP support that probably doesn't compile, but I added it as well. David says anything network. All right, well, I think I'm closer on the receive side. That changes probably. Did you do NTP? So there is an existing issue. Something else. Pavre 6. What else though? So there is this issue here that Patrick opened about NTP support, and I basically followed up today and I said like, I don't think we need native support for this. Like I found the Stack Overflow and it's like, I don't know, like 20 lines of code to be able to like just do one request from an NTP server. And so I was like, I don't really see the need to have that native. Changing the clock is actually something you shouldn't do willy-nilly. Like you should make sure that changing the clock is very deliberate. Yes. So Narrowdoc, that's another bug we just fixed. Says unsupported types are greater than none type in int. That happens if you don't get the contents of the request you made. And that is also, that has also been fixed. Lady Ada fixed it, and then I added unit tests for it. So if you look at the closed PRs, you can see this. The problem is that if it's a chunked request, we don't have remaining is set to none. So we had to add this check to make sure that remaining was actually a number. And then we would throw it away. Otherwise, if we're a chunked request, then there's a separate way to throw stuff out. And then I actually fixed it separately and didn't realize it, but I added unit tests. So you can just see here that like, under the chunk test, I like assert these are called, and then I close it, and that close would crash before I fixed it with the same error that you're seeing. BX2D Core says, glad you showed that you and Lady Ada know request.get was breaking the Titano learning project guide projects. Titano was my first foray into the Adafruit ecosystem, and like I said in the forum, My timing was unfortunate. Yeah, sorry about that. I felt really... I was very conflicted about those changes that I made for requests. Like, the networking stuff for PyPortal, the ESP32 SPI stuff, is stuff I'd really like to change because I'd like it to be better separated and also work exactly like... I'd also like it to work like CPython sockets. And like I went out on a bit of a limb with the 1.7 version of requests where I changed a lot of stuff. I thought I had done my homework to make it backwards compatible, but clearly I could only test so much. And this goes back to our testing discussion earlier of like, how do you test every learn guide automatically? Like that is like a holy grail for me. If I'm bad about manually testing, so having automated tests really helped me. So I've kind of pushed this new request thing on everyone, and it's broken some stuff, which has been unfortunate. But like, it now works with CPython sockets, so it's easier to debug there. And then on top of that, we now have unit tests. So like, yeah, it was kind of a bummer that like it didn't work like perfectly, but at least now like going forwards, like as we find issues, we'll add unit tests to fix them. I'm glad you learned a lot really fast, and sorry for that. I think going forwards, I do want to change the ESP32 SPI stuff, but I think the easier way to do it is to actually provide an alternative library that's just more focused and actually works exactly like socket. So I think that's kind of the way we'll go instead is we'll have like we have an airlift library. I think we'll add some Wi-Fi stuff there. Okay, so that's that. There was other questions. Benjamin says, but without correct date or clock, the certificate stuff will not work or not. Yes, you're right. I was just thinking about this. But that doesn't mean that you need the native NTP clock stuff to do it. What you can do is you can have, it's actually really straightforward to change the RTC clock. You just set rtc.datetime equals some other time struct. So doing it from Python alone is fine. Like you're not going to get like microsecond accuracy, but I think it would be within a few seconds, which should be fine. Maybe I'm wrong, and you can tell me I'm wrong, but I think it should be fine to set the clock from Python. You don't need native code to do it. So I was a little surprised talking about NTP. Maybe I'll just take a time code. Let's just talk NTP since we're talking about it. I was pleasantly surprised to find that it's actually a very simple protocol. What I was a little dismayed to find is that we have this Adafruit CircuitPython NTP library. Yay! And then I opened it up and I was disappointed because it doesn't actually implement NTP. All it does is it expects an ESP32 SPI module, and then it has this set time function, which I think is weird. But it sets the real-time clock's time to the time that it gets from the ESP module. I'm catching up on chat. So BX2D Core says, by the way, my interest in Titano was, besides buying something to support you guys, was as a companion to my Pi. The MQTT Home Assistant project got me interested. The other things were supposed to be easy. Hello worlds. Glad that hope is still alive. Yeah, sorry. That's like our selling point with CircuitPython is that it makes things easy, and networking is hard, and especially keeping it all working is hard too. But hopefully from here on out, not only will you have the experience to get over the little bumps, but hopefully it won't be as rough. David says, I'm a bit surprised that so many learn guides on Adafruit IO use Adafruit IO to get the time. That is so strange. There's a really simple reason for that, and that's because Adafruit IO, when you get the time from it, you put your time zone in. And so it allows the server to handle all the time zone logistics for you. NTP gives you UTC time, which is great if that's actually the time you go off of, but I don't think anybody does. Like there's too many complicated rules about like time zone offsets and daylight savings time changes and stuff that like it makes more sense to just have a Linux server that has all those rules feed you back the time. So that's why Adafruit IO is actually not a bad time source, and that's why they have it. Is just like you want to get the time for your time zone, like having it just a REST call for that makes a lot of sense actually. Bruce S says, looking at the generalized bootloader, it seems that you use IDF-Pi for the ESP32-S2 and make for the other ports. Follow-up attack. I looked it over, but that might be the case. And I'm potentially okay with that. Like, my concern is that the code's the same. If the build systems are different, that's not the end of the world to me. Benjamin says, NTP information which servers is usually provided via the DHCP from the network. I think when you connect to Wi-Fi, some module takes over to obtain the IP address, and then there comes information like DNS and NTP. Yeah, and Charles points out that it's the locale that is used to adjust the time zones. Unexpected Maker says, yeah, NTP is a pain, and there are dozens of libraries that try to solve making it easy in Arduino land, and most fail, and those that succeed are super complex. Yeah, exactly. Like there's a lot of logic around determining your time based on UTC, and so like by having just a service you can call. And David G says NTP info is not usually in DHCP. I mean, I think it's easy enough. Like I was disappointed by this, and like NTP was the first thing to come to mind. Like I probably will use IO because I want to use this. I want to use the upcoming thing as like a clock next to my bed. I think I will use just the IO service. I just hadn't thought about it first. But if you don't want to use that, basically what I did is, I think I have it. Probably pushed it. Nope. I forked it, but I didn't push it. Huh. Thought I did. Must be on my file system still. Let's add these. So basically what I did is I implemented it from Python. Shh, David G. Don't talk about AdaBox. Some people like it to be a surprise. But yeah, if you put your ear to the ground and take a look at what we're all working on, sometimes you can guess. Most people don't, though. Most people just get it sent to them and then they're surprised. Get status. Get, let's see, remote. Okay, you can see my thing. Remote. Add to new. Copy that. Ben Harper says, is GPS time already on the list of ideas? Same issues with UTC, though. I think we'd have to look at the GPS libraries, whether it exports. Like, ideally, I think what should happen is that any class that provides time, like a date time, should just have a date time field. And so if you wanted to synchronize, like, your internal S2's RTC to GPS time, you would straight up just assign it over. So I like, that's my ideal, is that like whereas the native NTP support will do things like adjust the clock every so often for you, I I kind of want to like leave it to the Python code to worry about that. Although it did cross my mind to, like the RTC class, the native RTC class does have a knob for tuning how fast it runs. But it did cross my mind to actually like raise an exception if you assign time backwards, because that can cause all sorts of havoc. So I think I might actually add that. So you'll only be able to set time forwards. And so if you end up with your RTC ahead of time, what you have to do is you just have to turn down how fast it runs. But yeah, if people have thoughts about that, let me know. It's like I kind of like rely a lot on like I don't want it to be super precise. But yeah. All right, let's at least get this pushed. Toddbot can't believe all the gerbils in this month's AdaBox. Yeah, Charles says like just have a small file that tells the system what the adjustment value is, like in Linux. Yeah, you could, but like figuring out what that adjustment value is, and as it changes over the year, is like much harder than just calling a different API that gets the time from like IO. Ben says, how would you recover from large clock drift? Like accidentally setting to 3020 or similar, set and reboot? Yeah, I would just like straight up hit reset. Yeah, because like you could power cycle it and you would lose it. David says, I have modified many learn guide code to replace Adafruit IO time with RTC time source. Maybe there should be an abstraction if you want to make a clock. Daylight savings is supposed to end in Europe, might make it easier. Yeah, I'd love to end it. Although this year, in the fall, we get an hour back, so it's not going to be as bad. I pushed, right? Okay. Yeah, Ben, I think that's answers your question. There is a way, also the RTC API actually allows you to, Notro did this code, and you can actually just set a different time source. You don't actually have to use the RTC. So what, like time.localtime will give you the time back. But if you actually look in the API docs for RTC, there is actually this set time source call. So you can actually provide a different object with the date time property, and it can be used as your time source for like time.localtime instead of the RTC at all, which I think is interesting too. So yeah, it's like early days, and then there's this calibration thing. So Jeff Epler is very much a time guru, I think, or at least a frequency guru. So maybe he'll come back through after I'm done and refine all this stuff. Okay, let's take a look at this. And as we look at this, let's just do a last call for questions. So if folks have any other questions you'd like me to talk about, we're just over our 2-hour mark. So if you have any last questions before next Friday, you can always ask me questions on the Adafruit Discord server. Just mention me at TanNewt. If it's a weekend, I might take a little while to get back to you. But also, please, if you are asking me a question, include the question when you mention me. Do not type a question, enter, and then at me without telling me what it's about. Because they pop up on my phone, and it's frustrating if they don't tell me why I got pinged. It's actually really bad because I try to, this is not what I wanted. Did I not commit? Oh, I didn't commit. Use. UDP to talk servers. Copy. Ugh. I'm just snagging my password for my GPG. Because I haven't signed my commits. All right. We're just about done here, folks. Git push. I just wanted to show this because I was like, I don't know, I thought NTP was really complicated. But the reality is that it's actually not that much. So the first 40 lines are imports and license header. And then I just implemented the property date time. And I have this math at the end. So basically what this does now is it tracks monotonic and compares it to the times that we get from the NTP server. So we only query the NTP servers as often as they say we can. And then if you request it faster than that, we'll just approximate it based on monotonic. So here you can see we're putting the packet together. I'll make it a little bigger. So putting the packet together to send to the NTP server, and it's actually dgram, which is also UDP. So it just sends it to the server, which by default is just the NTP pool. And then it receives a packet and it gets the size of the packet. It reads it back into the same packet buffer that we sent. We snagged the time that we got it, trying to get as close to like when it sent me a time to when we read a time. And then we unpack it, we compute. So this poll value is an exponent of how many seconds to wait until you query again, which actually varies per server, but I think it's fine. Like I guess we could abuse it if we got a like short server. We'll never request from the same server too fast because once we get a response from that server, we wait that long. So that's what next sync is, and then we get the actual time, and we even ignore right now. This is ignoring the fractions part, but this is only down to the second currently. But yeah, nice and simple, 87 lines. Kind of very much of what a CircuitPython library should be. Is like it should be very narrow, very focused, very small, just for one task. So should be able to get that in. The problem is that we don't have UDP support yet in the Feather S2. So I actually did start that work as well. I may actually not get that in. If anybody wants to pick it up, let me know. But like basically it's implementing receive from into and send to. Ignoring sub-second, you should do +1. Yeah. I mean, ideally we wouldn't ignore sub-second, but it is interesting in that like the protocol as written looks like you should like take the time that you send and then the server should return that to you, but I tried setting it and none of the servers sent it back to me, which I was a little surprised by. So that's why I'm doing this like more basic thing. I think the real way they kind of expect it to adjust is like you take the time that you send it, it gets the time it receives, and then the time it sends out and then back. So you like should ideally be able to account for like how long the network path is between you and get relatively. What is with these spammers? All right. Let me time these out. Anybody who speaks Spanish can let me know whether they're legitimate comments. But they don't look like it to me. Okay, so I'm going to call it. I'm going to actually try to get the receive fix out the door tonight, just because it's like really nice. And I don't think there's much work to it. So I'm going to do that off air because my voice is tired. It's been wonderful to see you all. As always, if you want to support me, please support Adafruit by going to adafruit.com, picking something up there that runs CircuitPython ideally. Helping us out and CircuitPython hanging out is always fun. If you want to join, if you want to keep chatting with us outside of the stream, you can go to adafru.it/discord. That will get on our Discord, and you can always mention me at TanNewt, or just post questions in the channels. There's actually like a lot of folks that can answer questions, not just myself. Happy to have the new S2 folks, and happy to hear hear that the new Feather S2s have UF2 on them. That's been great. And also shout out to Unexpected Maker, because I got an Espressif email today, and they pointed out that the Feather S2 is released as well. So congrats to Unexpected Maker for being the first out of the gate with the Feather S2. It's really handy. I was using it to test the Grayscale e-ink before I got the all-in-one board, which is really cool. Juan Carlos confirms that they are in no way legit Spanish comments. Thank you. Thanks for confirming that. Yes. Check your email. Maybe you didn't get it. But there was definitely like an Espressif newsletter that I got today. The Espressif ESP News, October 20th. Do they have a link to it? I can like it on Facebook. Here we go. Click this link if you want to see it. Let's pull it up. As a last celebration. So this is the MailChimp version of the email. And if we scroll down, we can see that the ESP32-S2 based Feather S2 has been released. So congrats to Unexpected Maker and all of you who are coming to CircuitPython as a result. We're happy to have you. And just expect CircuitPython to get better and better. With a few hiccups, of course. Anyway, thanks again. It's been wonderful. Have a great weekend. If you're in the US, don't forget to vote if you haven't already. Do not drop it in the mail. The mail is not that good. So always drop it off if you have a ballot. Return it to the appropriate place. And Tuesday we'll start to hear how that's going. So fingers crossed. Fingers crossed it goes smoothly, I should say. Anyway, again, Deep Dives Friday at 2 p.m. Join me. Next week will be Friday as well. And until then, I'll see you on the Discords. Thank you all. Oh, do we want to pet the cat? We can pet the cat. All right. Have a good one, everyone.